This is my latest animatronic project, which is brought to life by 16 individual servo motors. Animating a 1-minute sequence means to provide many different servo positions throughout the animation. This is where Blender proved to be a real game changer, since it helped me to achieve amazing results in a very short time. So today I'm about to show you how it works by using a Blender add-on I created for this specific purpose. When I started to program the servos for my first animatronic, I actually tried to define each of the positions manually by guessing and storing them in a text file. Not only was this super slow, but there was no way to see the actual result until I would update the code on my microcontroller. I then came across a video from the Disney Parks channel showing a sneak peek of their Beauty and the Beast dark ride. If you watch carefully, you'll notice that they animated their animatronics in 3D and projected the movements onto the actual figures. Applying the same principle to my project came down to exporting an animation to a format which can be used to position the servos. At this point, I already had a Blender model of the animatronic which I was going to 3D print. All I had to do was to attach the individual parts to some bones and I was ready to animate. I could suddenly add a few keyframes and Blender would fill in the frames in between, leaving me with a fluid motion. My first attempt was to export the animation to a BVH file, which is a format used to store motion capture data. This turned out to work really well, but required me to write a script in order to extract the desired rotation values and convert them to servo pulses. To make things easier, I decided to write a Blender add-on which can export an animation to servo positions directly, but also allows you to store the required settings for each of your servos. First, you will need to install the add-on by downloading the respective Python file from GitHub. You can find a link to the repository and the specific version used in this video in the description below. Open Blender, go to Edit, Preferences and click on the Install button. Select the downloaded Python file, click Install Add-on and make sure to activate it by enabling the checkbox. Let's explore the add-on by looking at a very simple example in which we assume that we have a single servo we want to animate. I therefore added an armature with a single bone. Since the servo can obviously rotate on one axis only, we can also add a bone constraint to limit the rotation. In this case, the bone can rotate on the z-axis between -90 and 90 degrees. This equals a motion range of 180 degrees, which matches the range of most hobby servos. With the bone selected in Edit or Pose mode, we can see that the add-on created a new panel in the bone properties called Servo Settings. Depending on your servo control technique, you will want to define different values for position min and max. Imagine them being the values to position the servo horn to the far left or the far right before it stops moving. For this simple example, I want to use the official Arduino servo library, which expects values in degrees. This is why I'm going to change the values here to 0 and 180, but I'll come back to the default values a little later. The neutral angle and rotation range values are just fine. For now we just need to make sure that the correct rotation axis is selected. Since we already limited the bone rotation to a range on the z-axis, that's what we want to select here too. For the animation, I set the end frame to 100 to keep it short and simple. I only added 4 keyframes rotating the bone to the left and right before setting it back to its neutral position. It is however mentionable that we are already benefiting from Blender's animation toolset. Switching to the graph editor shows that automatic easing has been applied. This will of course also help to get a smooth servo movement, which is exactly what we want when creating animatronics. We are now ready to export the animation and are presented with 2 formats to choose from when navigating to the export menu. The JSON format is a more generic option, but we are going to choose the Arduino header file format by clicking animation servo positions.h. Because we decided to use a value range based on degrees in our servo settings, we changed the precision to 2. You'll also notice a checkbox, which is already enabled by default, saying something about a procmem modifier. This will basically help with the small memory of typical microcontrollers like the Arduino Uno or Nano. We are about to create a large array which is normally put into the SRAM of the microcontroller. It is typically much smaller compared to the flash memory, as the Arduino Nano, for example, has about 32 kilobytes of flash memory but only 2 kilobytes of SRAM. This is where the procmem modifier file comes into place and tells the compiler to put the array into the flash memory instead, allowing you to run longer animations with multiple servos. Now let's finally export the animation and save it as a .h file. Next, we are going to look at a simple Arduino project, which is also linked in the description below. As stated before, this will require the official Servo library, so go ahead and install it if you don't already have it. The code calculates the current animation frame based on the total amount of frames, the frame rate, and the milliseconds since the program was started. The calculated frame is then used as an index to find the respective rotation value within the array. You can simply open the exported file and copy the array over to the Arduino code, or include the file directly if you want to keep the array separate. Depending on the animation, you might have to adjust the code to match your bone name, frame rate, and frame count. Before uploading the code, I will first connect an MG90S microservo to an Arduino Nano. I connect pin 9 to the yellow wire, ground to the brown wire, and lastly 5 volts to the red wire of the servo cable. We're finally ready to upload the code and see the animation in action. As you can see, the servo moves in the same fashion as previewed in Blender, with a bit of an acceleration in the middle of the loop. Now I know this isn't the most spectacular animation, but this setup allows you to easily extend and update it. There are still some servo settings which I previously skipped, but I hope that they are also easy to understand and use. The default min and max values we changed earlier refer to the usage of a dedicated servo driver, like the 16-channel PCA9685 module I used for my Phantom animatronic. At this point, I hope that I could give you a first impression of what's possible when using Blender to animate your servos. The add-on proved really helpful to me and should also allow you to easily try this process for yourself. Nonetheless, I think animating an animatronic figure in a similar way Disney does feels pretty amazing. Let me know if this video was helpful to you, and make sure to hit the like button and subscribe for more DIY animatronic content in the future. Also check out my other videos in case you want to see the final animations of my animatronic projects. Thanks for watching and have fun with your maker project.